but it was relatively flat. None of this was here. Now we'll talk about some of the rocks you can see here at the crater. We'll start with these red rocks. Just like the red rocks on the side of the road as you drove in, guys, this is the top layer of the Earth's crust in this part of Arizona. It's called Moenkopi sandstone. It's formed in the Triassic period. It's the youngest of all the rock formations right here. On average, about 30 feet thick. And then below this, it turns to a tan-colored rock called Kaibab limestone. The Kaibab limestone, guys, was formed in the late Permian period. It's a little bit older than this. On average, about 240 feet thick. Also formed in the Permian period, Coconino sandstone, the white, just like around mine shaft number 1. Well, that's the natural order of things. Red, tan, and then white below that. If we were to drill down in the desert, that's the order we would find those layers. Nice and neat. Looking out at the crater, you'll notice everything's a little bit backwards. Especially out here on the rim. We're not walking on red rocks. We're walking on the white and tan colored rocks. And you can clearly see that red rock formation. Make a nice ring right near the top of the crater. You can clearly see it on the south wall. And then the Kaibab limestone makes up most of the cliff wall. Well, guys, when the meteorite came in, it went through those layers. All that energy resulted in that explosion, uplifting. You can see the uplift right there. That uplift is about the same all the way around the crater. And then it threw out all the material we're standing on until it turns flat again. That's called the ejecta blanket. Well, guys, if you have a crater, you have an uplift like that, and you have an ejected material, you have to have had an explosion. You can't have one without the other. In the early 1900s, that was the main debate. What type of explosion was it? Was it a steam or gaseous blowout? Or could it have been a meteorite impact? It wasn't fully accepted by the scientific community until the 1960s. Really? Fairly recently, right? It was Dr. Eugene Shoemaker who finally helped answer those questions for us. Dr. Shoemaker was a geologist who had been studying craters in Nevada. The craters there, however, were man-made, nuclear test craters. Nuclear bombs detonated underground. They formed craters much like this one. The same structure, the uplift, the ejected material, right down to some of the changed materials inside the crater. Dr. Shoemaker was able to identify 2 minerals right here at the crater that do not occur naturally on our planet. Those minerals are called cosite and stishovite. That's the password to get back inside the building. No. Just kidding, guys. You're on vacation. Don't worry about it. Except for you. No, I'm just kidding. Just remember shocked quartz. Finding shocked quartz inside the crater finally gave us the proof inside the crater that they had been looking for. Not a meteorite, but proof nonetheless. Finding high pressure minerals in there gave us that proof. And because of the work that was started right here, nearly 200 impact craters have been found across the planet. Who can tell me where the largest impact crater in the United States is?
Right here.
Sorry guys, not this one.
Oregon?
Not in Oregon. Guys, the largest impact crater in the United States is the Chesapeake Bay. You've heard of it, right?
Yeah.
Washington, D.C. area, coast of Virginia, Maryland. From rim to rim, our crater is 1.2 kilometers in diameter. The Chesapeake Bay impact crater is 85 kilometers in diameter. So it's like 80 times bigger than this one almost. It's big. It's all underwater. You can't drive up and look at it, sorry. Largest impact crater on the planet. I know I'm making you guys think too much.
Yeah, isn't it South America?
South
Caribbean.
Africa.
Okay.
Really?
Yeah, the largest one in the world, guys, is in South Africa. The name is Vreederfort. From rim to rim, and it's all on land. Imagine a crater from here to south of Phoenix, or 187 miles in diameter.
Wow.
Massive. It's also dated to be about 2 billion years old, so it's one of the older ones. Now, you guys were talking about the Yucatan, right? The Chicxulub impact. You guys heard of it?
Pointing at you.
You heard of that one? Happened 65 million years ago. The meteorite that formed this crater, guys, was 150 feet in diameter. The one that impacted the Yucatan, they estimate, was 6 miles in diameter. That's from here to my home at the RV park. When it impacted, guys, they believe that mass was equivalent to Mount Everest. So it was quite big, quite dense. Formed a crater 105 miles across. But the key part about that impact, guys, is the dust cloud that it threw up. Completely covered the planet. And it was so thick, the sun couldn't even shine through. And it stayed up there for so long, with no sun on our planet, it completely upset the ecosystem of the entire world, eventually leading to the extinction of the dinosaurs and most life on Earth at that time. Our impact was much more of a local event. When this impact occurred, any living mammal within 7 miles would have been killed instantly by the shockwave. My home at the RV park just blown away. Severely injured up to 14 miles in every direction. Hurricane force winds 21 miles away. After that, most of the dust from this one would have settled fairly quickly. Not a global event, but could you imagine one just this size impacting a populated area today? It'd be catastrophic, right, guys? So on that unhappy note, any questions?